Hello guys, how are you today? So today I'll be continuing the explanation of chapter 3, the things we did not take last periodic. So in the previous video we discussed about strong electrolytes and weak electrolytes and acids and bases. Now let's mix them together. Together we're going to have that a strong electrolyte means what? It means a strong acid, okay? Whereas a weak electrolyte means a weak acid. Now, the only three you need to know, the only three strong acids that are gonna come are HCl, HNO3, and H2SO4. If you remember these three acids, then everything will be simple. Why? Because if they ask you for a strong acid, you choose 1, 2, 3. If they ask you for a weak acid, you choose everything except these. So HCl, HNO3, and H2SO4 are strong acids. Everything else is a weak acid. Now, talking about strong acids and weak acids, we also have strong bases and weak bases. Now, of course, again, I'll open a new page. A strong electrolyte means a strong base, and a weak electrolyte means a weak base. The only two bases you need to remember are NaOH, these are the strong bases, and KOH, only these two. Everything else they will give you is a weak base. Now, what exactly do they mean by strong acid and weak acid, strong base and weak base? Very simply, if you are going to write their breaking, for example, their ion formation, we're gonna take HCl. HCl, because it's a strong acid, it takes only one singular arrow, and then it will break into H plus and Cl minus. However, if it was a weak acid, for example, HF is a weak acid. We're gonna have HF, it will be in equilibrium. This means it partially dissolves, it partially ionizes into H plus and F plus. So when they're telling you strong acid, that means you draw one arrow. It fully ionizes, it fully breaks into ions. If they tell you a weak acid, you put the equilibrium sign, meaning it is a reversible reaction, meaning it does not fully ionize, it partially ionizes. Same thing for the strong bases. You have NaOH. Because it is a strong base, you're gonna put one arrow, it becomes Na plus and OH minus. But for example, if we're talking about CaOH2, it is a weak base, so we will do the equilibrium sign because it partially breaks into the ions, which are Ca2 plus and OH minus. I did a mistake here. It is OH and then you close the brackets too. Alright? Now, always know that equilibrium in the strong base or acid always favors the products. So equilibrium in the strong acids or bases always favors the products. However, equilibrium in the weak acids or bases always favors the reactants. Okay? Now, of course, the stronger the acid, the base, I'll just write it over here, stronger acid or base means what? It means a larger equilibrium constant, which we are going to denote as KEQ. So a stronger acid or base means a larger equilibrium constant. Now, since we're talking about acids and bases, you have something called dibasic or diprotic. When we are talking of dibasic or diprotic, they mean the same thing. We are talking, first of all, about an acid. What about this acid? This is an acid that can give two, di means two, negative ions. Okay? For example, H2SO4 is what? It is a dibasic or diprotic. Just look at the H. Does the H have two Yes, if this is the case, then it is diprotic. How do we know? You can split them into the ions. You're going to get H plus and SO4 2 minus. So it's an acid that can give two negative ions. These two negative ions are not to the H, but to the other element, in this case. Not element or compound. Now we move on to the types of reactions that can happen. Okay, but one thing we need to know is that they're all happening between acid and base or metals, okay? And the only two metals that do not react. So metals that do not react are Cu copper and Ag silver. These, they do not react in what we are going to mention right now. Okay, so please keep in mind we have 7 equations which we need to memorize because they are very, very important. So the first thing we are starting with is an acid added to a metal. Whenever you add an acid to a metal by itself, it's going to give us a salt plus hydrogen gas. Let's take an example, okay? As an example, we're going to take an acid, 2HCl. This is in the balanced form already. 2HCl is always aqueous. In addition to a metal, any random metal you want, for example, Na solid, or let's say 2Na solid. This means it gives a full reaction. So it gives a full reaction to form a salt plus H2 gas. Now what exactly is the salt? If we removed H2 gas, okay, then we are left with what? We are left with 2Na and 2Cl. So our salt is going to be 2NaCl solid. So our first example is acid plus metal gives us a salt plus H2 gas. An example equation is 2HCl plus 2Na solid will give us 2NaCl solid plus H2 gas. Okay? The second thing we will be talking about is the acid plus the metallic oxide. So, acid plus metallic oxide, I will denote it by MO, will give us a salt plus water, H2O, liquid. So an acid plus a metallic oxide will give us salt plus H2O, water. If we are going to take an example, for example, we are going to do 2HCl plus FeO. Okay, so this is an acid plus our metallic oxide, which is iron oxide, will give us, as a salt, it will give us FeCl2 and water plus H2O, liquid. Always this one, in this case, is aqueous. And here, I apologize, this is also aqueous. So the first one is acid plus metal gives us a salt plus hydrogen gas. Second one is an acid plus a metallic oxide gives us salt plus water. Now we have something really nice, number 3. It is called the neutralization reaction. Why is it called a neutralization reaction? It is because it is an acid plus a metal hydroxide. Okay? So an acid plus a metal hydroxide. An example of a metal hydroxide is NaOH, which is a base. So if you're adding an acid and a base, this is a neutralization reaction. What do you get from a neutralization reaction? You are going to get salt, of course, and water. If we are going to take an example, for example, if we are going to take H2SO4 plus KOH, which is a metal hydroxide, it will then give us, also remember this is aqueous, and this is also, I believe, aqueous. It will give us a salt. What is the salt? This salt is K2SO4. This is our salt and it is aqueous, in addition to water. Now, if we check, is it balanced? We have a small contradiction. It's not balanced. So to make it balanced, very simply, we're going to put a 2 over here and a 2 over here. And now, if you look at it again, it is balanced. Because we have in total here 4 H's and here 4 H's. Here we have SO4, here we have SO4, and here we have 2 K's and 2 K's. So it is balanced. That is number 3. That is criteria number 3 done. Next thing we have is an acid. So we finished number 3, now we move on to number 4. We have an acid, okay, plus a metal carbonate. Acid plus metal carbonate is gonna give us salt plus water plus carbon dioxide gas. An example of an acid, for example, 2HCl plus a metal K2, for example, carbonate, so K2CO3, will give us, as a salt, it's gonna give us 2KCl, okay, in addition to H2O, liquid, and in addition to carbon dioxide gas. Let's check, is it balanced? Yes, it is balanced. So this is our 4th criteria done. Now, moving on to our 5th criteria, we have an acid plus a metal sulfide. What happens when you add an acid to a metal sulfide? You are gonna get salt plus water, which is H2O liquid, plus sulfur dioxide gas, SO2 gas. An example of this would be an acid is H2SO4. In addition to a metal sulfide, for example, Na2SO3, this is a metal sulfide, will give us a salt. What will our salt be? Our salt will be Na2SO4. Of course, this one is aqueous. Okay. In addition to water, H2O liquid, and SO2 gas. Now, if we look at it, we are gonna see that it is balanced. Since it is balanced, we move on to the next criteria, which sounds similar but is different. It is number 6, an acid plus a sulfide. So it's not a metal sulfide, it is acid plus sulfide. What will it give us? It will give us a salt plus H2S, which is hydrogen sulfide gas. This is a gas. Now, an example of an acid can be 2HNO3 plus a sulfide, which is FeS. It will give us a salt. What will the salt be? The salt is definitely going to be FeNO3 plus H2S gas. Now, if you check, it is all balanced. Now, we're going to move on to the last criteria, which is criteria number 7, which is about a base now. We finished acids. Now, the 7th criteria is a base. It is a base plus an ammonium salt. What happens when you add a base to an ammonium salt? It is going to give you a salt plus water plus ammonia. For example, a very famous base is NaOH. If we add it to ammonium salt, for example, the ammonium salt is NH4NO3. It will give us a salt. This salt is NaNO3. And it will give us water, which is H2O, and ammonia, which is NH3. Now, if you check, is it balanced? Yes, it is balanced. So, that means we finished with our 7 criteria. One more thing, like before we move on to the next topic, we are just gonna know some precipitates that are used to find cations. Precipitates to find cations. I don't know why they told us about it, but it's just nice to know. We have CuOH2. How do we use it to find cations? Because it gives us a flame. We use the flame test. And also it gives us a precipitate. Then FeOH3, it gives us as well a precipitate. Then FeOH2 will as well give us a precipitate. AlOH3 will give us a precipitate. AgCl will give us a colorful precipitate. AgBr will as well give us a colorful precipitate. AgI as well will give us a colorful precipitate. And finally, PbCl, to basically everything that is insoluble that we used it to find the flame test or the precipitate reactions, if you remember, like Fe3 plus, Fe2 plus, Fe3 plus. If you remember, it had a reddish brown precipitate. Yeah, all of these we can use them to find cations. Okay, this is just what we needed to know. Oh yes, and also some binary salts can form by doing metal plus non-metal, metal plus non-metal. For example, if you have Na, which is a metal, plus Cl, which is a non-metal, you are gonna get NaCl. Okay, this is a binary salt. It is prepared directly by combining their two elements. Now we can move on to something really nice. We have salts. Okay, we have two different types of salts. We have the soluble salts and the insoluble salts. Let's start off with the easy ones, which are the insoluble salts. All the insoluble salts, they have the same experiment or the same reaction to make them a salt, which is precipitation. Precipitation, that is formation of a precipitate. Okay, so please always do remember, in the precipitation we form a precipitate and we dry it by evaporation. Okay, however, for the soluble salts you have two methods. Now, if you are talking about the cations, method 1, if you're talking about the cations, Na+, K+, or NH4+, if you're talking about any of these three cations, then you are going to be using titration. I forgot how to spell, I'm so sorry. Titration. Okay? Now, for the other ions that are not Na+, that are not K+, and that are not NH4+, we do not use titration. Instead, we have the different things that we talked about over here. So if it's not Na+, if it's not K+, if it's not NH4+, you can use one of these over here, if you know what I mean. So I'll write here one of the 7 methods. Now, how we usually dry this is by crystallization, because they are soluble, so then we have to use crystallization for it. So again, a quick summary, we have two types of salts, soluble and insoluble salts. Insoluble salts, they have only one method, which is by precipitation, and then we dry it by evaporation. Then soluble salts, if they are Na+, K+, and NH4+, we use titration. If they are not any of these ions, then we use one of the 7 methods mentioned above previously, okay? Now, the last thing I'll be talking about is the equivalence point, or the stoichiometric point. In the equivalence point, so we write it like this, equivalence point, which is also known as the stoichiometric point. It is the smallest, it basically means the smallest amount of titrant, meaning the product or the liquid of titration, okay, that is sufficient, okay, to fully neutralize or react with the analyte. Now, you may be wondering, what is an analyte? An analyte is the thing being measured, or the substance being measured, okay? So just know, the equivalence point, or the stoichiometric point, is the smallest amount of titrant that is sufficient to fully neutralize or react with the analyte. I remember one time they gave us a graph and they asked us to find the equivalence point. It's in the middle. This is logical. Now, one thing you should also know about the equivalence point is that the concentration of H+ is, in this point, is equal to the concentration of OH-, which is equal to the radical of Kw. If Kw is 1 times 10 to the negative 14, that means the radical of Kw is 1 times 10 to the negative 7. Alright, and once you apply these rules and you solve a little bit more, you will get one final equation, which is that the concentration of acid multiplied by the volume of acid is equal to the concentration of base times the volume of the base. Thank you guys for watching. I hope you enjoyed the summary and have a wonderful day and do good in your exams tomorrow.